Hey everyone, and welcome to this explainer. Today we're going to break down how a modern engineering marvel suddenly became the setting for the longest unpowered passenger jet glide in history. We're looking at the absolutely incredible, terrifying, and ultimately miraculous story of Air Transat Flight 236.
Picture this. You're sitting in a dead silent cabin with 306 people suspended in a 150-ton metal tube high over the dark Atlantic Ocean, and you hear those terrifying words being broadcast from the cockpit. No engine hum, no power, literally just the sound of the wind rushing past the fuselage.
So you really have to wonder, how exactly does a computerized, state-of-the-art airliner suddenly just become a glider? Well, let's dive right into this incredibly tense story. We're going to see how a cascade of mechanical failures, mixed with some really tricky human-computer interactions, brought a fully loaded Airbus A330 right to the brink of disaster.
All right, part one, the impossible glider and a cascade of warnings. To really understand this life-or-death crisis, we have to trace their flight path. Just hours after a totally calm takeoff in Toronto on August 23, 2001, air traffic control moved the plane 60 miles south of their original route just to avoid some congestion. Now keep that in mind, because that minor little routing tweak literally ended up saving all of their lives. Because about 5 hours in, that perfectly smooth flight abruptly ended with a very, very strange warning.
Now here's where the irony of modern technology really kicks in. The cockpit computer flashed a warning for low oil temperature and high oil pressure on the right engine. And because that specific combination is just so bizarre, oil temperatures normally go up during a malfunction, not down, the pilots naturally assumed it was just a software bug, right? Not a physical catastrophe. They had absolutely no idea they were actually looking at the symptoms of a massive fuel leak that was actively contaminating their oil system. Which brings us to part two, a cascade of warnings and the fuel running dry. Let's look at the exact moment where totally standard airline troubleshooting actually accelerated this entire crisis. 20 minutes after that initial oil alarm, the computer warned of a fuel imbalance, basically saying there was too little fuel in the right wing. So the pilots dutifully followed their standard Airbus checklist and opened what's called a crossfeed valve. Think of this as opening a pipe that connects the left and right fuel tanks to balance them out. But tragically, because they still thought they were dealing with computer glitches and couldn't actually see the leak, this action pumped all their good fuel from the left wing straight out of the hidden leak on the right.
Because they were flying in the pitch black of night, they couldn't see the massive stream of jet fuel trailing out behind the wing. Even shining flashlights out the passenger windows revealed absolutely nothing in the darkness. So as a result of opening that valve, they accidentally dumped an astonishing 17 tons of fuel into the sky in less than 30 minutes. As the gauges dropped to zero, the terrifying reality finally set in. The computer wasn't lying to them.
Moving on to part three. The fuel runs dry, and we get a massively high-stakes landing.
With the tanks completely bone dry, the right engine flamed out, followed just 13 minutes later by the left. Just like that, a state-of-the-art airliner became a massive, plummeting glider. When the engines died, the plane lost all its main electrical and hydraulic power. The cabin went dead silent and began depressurizing. The only thing that kept them alive was this tiny, wind-powered propeller called the ram air turbine, or the RAT. It drops right out of the belly of the plane, spinning in the rushing wind to give the pilots just enough basic control to steer their heavy glider toward a military airbase in the Azores, which thankfully was only within reach due to that 60-mile route change they made earlier.
But even with a little bit of steering control back, the stakes were unimaginably high. They were losing 2,000 feet of altitude every single minute they spent over the water. And ditching a massive plane with a low-mounted tail in the ocean, that usually results in the fuselage completely ripping apart. They had to make that runway. They literally had one single shot.
As you can imagine, this was absolutely not a standard approach. Without engines to power the wing flaps, they couldn't slow the plane down properly. Coming in incredibly fast and heavy at over 200 knots, compared to a normal 170, the captain was forced to execute these aggressive, violent 45-degree swerves, dramatically dipping the wings just to bleed off that dangerous speed before slamming onto the tarmac.
The Airbus hit the runway incredibly hard, bursting 8 tires upon impact. With only emergency brakes working, they somehow managed to stop just short of a 400-foot cliff at the very end of the runway. The evacuation was frantic, deeply emotional, and clearly fueled by pure adrenaline. One passenger even recalled that they didn't slide down the emergency chute. They literally ran down it just to get out. But miraculously, all 306 people survived.
So let's look at Part 4, a high-stakes landing and uncovering the fatal flaw.
With everyone safely on the ground and the immediate terror over, international accident investigators immediately dug in. And what they found is a textbook example of the Swiss cheese model of disasters, where multiple small errors perfectly align to create a total catastrophe. See, just 5 days before the flight, Air Transat swapped the right engine, but the replacement from Rolls-Royce arrived missing a hydraulic pump assembly, so mechanics patched it together using older, mismatched parts from another engine. Without the proper securing bracket, a hydraulic pipe and a fuel pipe were left rubbing against each other constantly for 5 days, until the vibrations finally fractured the fuel line mid-flight.
Guys, it all came down to a space of just 3 millimeters. That was the clearance the missing bracket was supposed to maintain. Because that tiny 3 millimeter gap was ignored, mostly just to avoid the cost of grounding the aircraft to wait for the proper parts, Air Transat was slapped with a $250,000 fine. At the time, that was the largest fine in Canadian aviation history.
Finally, Part 5, uncovering the fatal flaw and the lessons we learned from Flight 236. So what can we actually take away from this terrifying incident? How did nearly losing 306 people change aviation software and training forever? Well, a massive takeaway here is overcoming the psychological trap where pilots distrust their own instruments. Because these pilots were overwhelmed by thousands of computer sensors and totally bizarre warnings, they simply didn't believe they were actually losing fuel. To fix this, Airbus completely redesigned its software. Now, the systems explicitly calculate overall fuel loss against what the engines are actually burning. If there's a discrepancy, it clearly and immediately alerts the crew to a fuel leak, entirely preventing them from blindly opening crossfeed valves and dumping their remaining fuel.
The legacy of Flight 236 leaves us with a truly miraculous story of survival and some downright brilliant flying under pressure. But it also leaves us with this vital question. As our machines become infinitely more complex, how do we balance the incredible safety of automated systems with the sharp situational intuition human pilots need when those systems break down? Thanks for joining me on this explainer. I hope it helped you understand the incredible mechanics and human decisions behind the impossible glider.